Hey guys, welcome to day 2 of polar. Yesterday it was polar coordinates, and today we're going to talk about polar equations. Okay, so we're used to equations with x's and y's, and since x's and y's can also be written as r's and thetas, you can also have what are called polar equations as well. And today you're going to see some polar equations, and we're going to graph them. Now we're going to start off with some really basic polar equations, like r equals 5. Well, that literally means the radius is always 5. So if you have this graph, you can just go out 1, 2, 3, 4, 5, and that would be a point that would be on this graph, but it's not the only point, okay? R equals 5 means whatever your angle is, r is 5. So it's not this point, it's every point that's on this circle. Okay, it's this angle 5 and this angle 5 and all the points in between them. So all you do is go out to that fifth circle and then trace it to the best of your ability. I have to turn my paper. It's the only way my hand works. Okay, so that is the graph of the polar equation r equals 5. Real easy. The next one says theta equals negative pi over 4. So let's find that angle. So this is pi over 4, right? That's pi over 4. So negative pi over 4 would be right here. Negative pi over 4. Now, theta always equals negative pi over 4. The r can be anything. Okay, so what it is, it's going to be a straight line that goes towards the angle, but also goes away from the angle. Why? Because those would be all the negative r's. Okay, so r can be anything. R could be 1, 2, 2.2, 2.3, whatever, but it could also be negative. So all of these going that way as well. So that is the graph of the polar equation theta equals negative pi over 4. Okay? The third example, r sine of negative 3. Now, here in a second, I'm gonna show you some equations where we're actually gonna type things into our calculator. This one, it does look like there's some operations going on, but we don't need to put this in our calculator. R sine. From yesterday, we talked about, we were converting between x's and y's and r's and thetas and everything, and we found that y is equal to r sine theta. So this is something we're actually familiar with. This is just like y equals negative 3. Now, it's a little harder to graph on this. Y equals negative 3 would be go down 3, and then draw a horizontal line. But we don't have a horizontal line. We've got these circles. Okay, so to the best of your ability, draw a horizontal line, and you're going to try to look at this polar axis and see if you can just kind of make it parallel. Ooh, I'm already going off. Something like that. That's not too bad. Okay, so that would be r sine equals negative 3 because r sine is y. If I would have given you r cosine, then that would have been x. Okay, and so you just translate it into x, think it's a vertical line, and then you just go out to where you need to go out. All right, but here's where they're going to get a little more interesting. Okay, we're going to graph this equation. R equals 1 plus cosine theta. And again, this is where I think of these backwards. Theta is going to be our input. R is going to be our output. Okay, so even though they write the points r theta, that's not how I look at it. Okay, I look at it as theta. We're going to plug this into the equation, and we're going to get these r values. So what you're going to do is you're going to grab your calculator. Notice that all of these are in degrees, so we need to make sure our calculator's in degrees. Mine is. It's got the little DEG right there. And then just one at a time, we're going to put these values into this equation. So what is r if theta equals 0? So we're going to do 1 plus cosine of 0, and we're going to get 2. Okay? And then we're going to do our next one. We're going to do 1 plus cosine of 30. So what's that? I'm going to write 1.86. Technically, I'm just going to write 1.9. Okay, when we graph these, okay, going out a tenth is going to be hard enough. There's no way you can go out to like the hundredth place and you can tell the difference between 1.86 and 1.85 or whatever. Okay, so going to the tenth will probably be good enough for our graphing. All right, 45. 1 plus cosine of 45. 1.7. Okay, so we're just going right down the line. 1.5. Just stay with me. Keep going. I'm going to show you a little trick here in a second. Cosine of 120. What do we have? 0.5. Okay. 1 plus cosine of 135. We'll call that 0.3. So 0.3. 1 plus cosine of 150. Ooh, 0.1. I'm just going to call that 0.1. Sorry, there's a glare. There you go. You can see mine a little bit better. 180. 1 plus cosine of 180 is 0. Oh, cosine of 180 is negative 1. And then negative 1 and 1. Okay, 0. All right. How about 210? Let's see what happens when we do this. 1 plus the cosine of 210. And we have that 0.1. I feel like we already saw this. Right here. 0.1. These graphs are symmetrical. And so once you get a repeat, that repeat is going to continue. Okay? If this is 0, and then 30 degrees from this is 0.1, but also 30 degrees past 180 is also 0.1. I guarantee that 225 is going to be 0.3, 240 is going to be 0.5, and then 1, 1.5, 1.7, 1.9, and then you're always going to end where you started. Okay, 0 and 360 are the same. They're the same angle. So if that has a value of 2, that should have a value of 2. And that's our T-chart. Okay, that's all we're doing. We're doing T-charts that we need to come over here and graph. Okay, so let's take a look at this. All right, so a couple things. First off, my graph goes 1, 2, 3, 4, 5, 6. Okay, so my outer ring is 6. If you look at the numbers I have, the biggest R value I have is 2. So this entire graph is going to take place inside this circle right here. And I've got a lot of decimals that I'm going to have to try to figure out. What's the difference between a 1.9 and a 1.7 and a 1.5? So another thing we can do is we can scale this. Okay, just like you can scale an X and a Y to make things fit better. Okay, I'm going to scale this. Scale by 0.5. So this is not 1. This is going to be 0.5. This is going to be 1. This would be 1.5. This would be 2. And that's as far as I need to go. Technically, I could have scaled it by a third, I guess. And then this could have been 2 out here, but that would have been even trickier. Okay, so this is what we're going to do. That's 0.5, 1, 1.5, and 2. So what I've done is I've taken this graph that we're going to graph. I'm going to blow it up a little bit so we can see it better. Okay? If you do not do that, you're just going to get a picture like on your homework. If you don't do that, your picture is going to be smaller than mine. Doesn't mean it's wrong. It's just it's not going to look exactly like mine when you check your answers. Okay? So let's see what we got here. We've got 0 and we've got 2. So 0, 2 is right here. Then 30. Now that's not the next line. This is 15 degrees. Okay? Here's 30. Okay? 30 and 1.9. So here's 2. I'm going to go around. I'm just going to go around this curve. Here's 30. And then I'm going to go in a little bit. There's 1.9. 45, which is the next line. So what I do is I just jump right over to the next line. There's my angle. And then I back up a little bit. I need 1.7. Well, this was 1.9. This is 1.5. So it's going to be like here. At 60 degrees, I should actually be at 1.5. So the next line would be 60. And that's 1.5. Oops. My pen left a little dot there. That's not a point. And then 90, I'm at 1. So remember, this is a half, this is 1. Now, what I do is, this is like quadrant 1, okay? Let's stop and let's graph what we've got so far. So this graph starts here. It goes up, hits that point, and comes to here. All right, that looks a little different. Okay, and then let's keep going. So now 120. So think about it. This is 120. This will be 135. This will be 150. And this will be 180. Okay, feel free to label your angles here. So at 120, I should be at 0.5. I should be right here on this first circle. 135, I'm at 0.3. So a little bit more than halfway. At 150, I'm at 0.1. So here's 150. Maybe that was a little off. I'm right here. And then at 180, I'm at 0. All right, so again, I've gone, this was quadrant 1. This is quadrant 2. Let's stop and graph this. Okay, and then let's keep going. 210, so here's 210. I'm back at 0.1, so I'm out just a little bit. This is 225. That should be at 0.3, so a little bit further. Then I should be at 0.5, and then I should be at 1, right, at 270. I'm going to stop, draw what I've got. I have to try to purposely slow down. I graph these a little faster. I've done quite a few of them. These are going to be brand new to you. Okay? And then, again, keep going. We've got to connect these. So this was 1. 300, which is here, is 1.5. So there's 1.5. And then I should be at 1.7, 1.9, and then back around to 2. So I need to connect these. And that is our graph. Okay, it looks a little weird, different than anything you've ever graphed before. That has a name. It's called a cardioid. Okay, take a look at it. See if you can see why. Okay, cardioid. If I turn this around, kind of looks like a heart. The top here looks like a heart. Okay, and then it's kind of more rounded off, but still that top part looking like a heart. Looks like when you try to make those valentines in elementary school, and if you didn't make it right, you would maybe not get a heart that looked exactly right, but the top part sure looks like a heart. Okay, that cardioid can go in a lot of different directions. It could have looked like an actual heart, where this part was up here at the top. If I would have had a sign, that's what would have happened. Okay, you've got a 1 plus sign, you got a 1 minus sign. Those are going to look more like hearts, whereas the 1 plus cosine had the fat part going to the right in the positive cosine. A minus cosine would have made it go the other direction. Okay, but that's called a cardioid. Okay, so 1 plus cosine of theta will give you a shape that looks like that. Okay. All right, next page, we've got another example of a polar equation. So again, here's our equation. R equals 4 plus 2 sine theta. Okay, so one at a time, we're going to put each of these angles in for theta. Put them in our calculator. So for example, we're going to have 4, just type this part in, 4 plus sine, and then, 2 sine, and then theta, so 0. So type that in, and we get 4, okay? Then we're going to do 4 plus 2 sine of 30. That's 5. You can also, so if you see I just scrolled up, and I can go back into my equation. I can change the angle to 45, so it's 5.4. And scroll up. 60, 5.7. So it may save you a little time. 6, 120. Now, 5.7, we already had that. So again, whenever you have a repeat, that means you're seeing some symmetry here. So I can save myself even more time by doing, I know the next one's going to be 5.4, I know the next one's 5, and I know the next one's 4. Now, that's where my symmetry is going to end for now, so I need to go back to the calculator. I need to figure out what 210 is. So 210 is 3. 225, we'll call that 2.6. 240, 2.3, 270 is 2. 300 is 2.3 again. So again, there's my repeat. So the next one's 2.6. The next one's going to be 3. And then the next one is going to end where I started, which is 4. All right. So take a look at my, I don't know, I guess you would consider, I consider them the Y values, okay? The answers that I got over here, my R values. Okay, so the biggest one is a 6. So if you look over here at my little concentric circles, that's 1, 2, 3, 4, 5, 6. So I just need to scale this normal. We're going to go out 1 circle for 1, 2 circles for 2. So start with 0, 0, 4. So 1, 2, 3, 4. Then at 30, so remember this is 15 degrees. We're not using that. This is 30. We're going to be out at 5. So now we're at 5. At 45, we should be 5.4. So just a little bit inside of being like a half. 5.7, so now we're getting closer to the edge, and then we get to 60. Now, I would stop, and I would connect those dots. Now, to make mine work the way my hand wants to move, I'm going to turn it. You don't have to be that perfect or precise. This is just for the notes. All right, so where am I? So 5.7. So again, 120, 135, and 150. These are the three that are right next to each other. So I'm going to skip that. And then this is 135. This is 150. And then this is the, this is 135. And this is 150. Okay? So much for being precise for the notes. All right, so now at 120, I should be at 5.7, so now I'm starting to come back down. 5.7, then it was 5.4, then it was 5, and then it was 4. Stop, connect your dots. Okay. All right, so that's 180. So now 210. So here's 210, 225, and 240. So at 210, I should be at 3. So go back to this center. 1, 2, 3. Here's 3. Now, the next line is at 2.6. So I'm just going to go down to the next. Oops. Man. This is 210. This is my 3. Ignore that little dot. That's 3. Here's 2.6. Here's 2.3. And then I should be at 2. So there's 272. And now I'm going to start to come back out. Here's 2.3. Here's 2.6. Here's 3. So these connect down. Then they start to straighten out. Kind of make this little straight line kind of on the bottom. And we get that. All right, and that is our shape. This is called a limicon or limicon or something. It's like French. Okay, and it actually in French it means snail. And if you look, this is like a snail shell or something, or a clam shell, or it looks like some kind of shell. Okay, but that's what this shape is. Okay, all right. Next one. Okay, so this is the next one. So, here's what I want you to do. pause the video and then try to find all these values on your own, and then hit play after you've done that to check them with mine. Alright, so here's the values you should have got. So it starts with 1, the numbers are getting up, 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 up. They go up to 4, then they start to repeat, so they're going back down. Then they go negative. That's okay. If you got negative answers, you did not do anything wrong. Okay? When you take the sign of these angles that are in quadrants 3 and quadrants 4, you get negative values. Same thing happened on the one before. But on the one before, those negative values were getting multiplied by 2. These negative values are always like less than 1, like negative point something. Okay? So when we took that negative number, multiplied it by 2, we were getting a negative, but it was less than 4. So this bigger number was kind of canceling out that negative, and we never saw it. On this one, that negative number is getting multiplied by 3. So this is going to end up being a bigger negative number than this one that's out front, and that's why we're seeing the negatives this time. Now, let me give you another little hint. This shape is called a lemicon with an inner loop. So what's going to happen is we're going to get a shape similar to what we had on the last one. So let's go ahead and start this. So all right, so again, I'm up to 4, so I'm just going to scale this normal. The biggest number would have to be a 3 for us to be able to kind of blow this up. So we're just going to scale it normal. So 0, 1, 30, so remember that's this line. The last graph I did, you could see that even I have trouble sometimes skipping these. It's kind of hard to do. Alright, so 2.5. So here's 1, 2, 2.5. And then at 45, which is the next line, I should be up at 3.1. So just past 3. Then 3.6. And then I'm up to 4. And then I'm back, so I'm going to skip this line. I'm back to 3.6, back to 3.1, back to 2.5, and then back to 1. Now, if I did that faster than you, don't worry about it. I've graphed a few of these in my time. And if you stopped at 90, if you want to stop at 90 and then connect the dots, I did the first half. Alright, so here's where things are going to get interesting, because this is where we start getting these negative values. So again, this is 210, 225, and 240, and then 270, 300, nope, 315, and 330. Alright, so here's what's going to happen. 210. Now, if you need a straight edge, because remember, we're going to be drawing backwards now. Okay, so I'm going to go in that direction. So at 210, I need to be at negative 0.5. So here's my line. So at 210, I'm at the pole, I'm going to go backwards about 0.5. About a half. Okay, and then at 225, so here's 225, right here, but I'm going to go this way. I'm going to go the other way about 1.1. So the circle is 1, so it's going to be just past the circle. And then at 240, I should be at negative 1.6. So again, I'm going this way. I'm going towards 60. 60 is across from 240. Okay, I'm going to go 1.6 and then 270. So again, here's 270, but I'm going away from 270. I'm going towards 90. 1, 2. So here's what's happening. These curl up. And then keep going. So at 300, so here's 300, but this way. So here's 1.5, so it's 1.6. So it's about 1, in between 1 and 2. 315, I should be at 1.1. And then I'm back to somewhere and a half, and then I'm back to where I started. And you get that. That is a limicon. So there's the shell with an inner loop. So it does this, it goes a big circle, and then it does this little loop-de-loop in the middle. Okay, just like a little roller coaster loop-de-loop. And that's what it is. And again, it's caused by that number being bigger than that number. On the other one, the first number was bigger, and it kept everything positive. So that's that one. All right, last page. So take a look at the one at the top. A little different. There's no addition going on here. This is simply 2 times the cosine of 2 theta. Okay, so that's what's going to get plugged in. Let me get you started. So 2 times cosine of 2 times, and then whatever your theta is. In this case, it's a 0. Okay, so that gave me a 2. And then again, you can go up and you can change that 0 to a 30. You'll get a 1, and then you can keep going. Okay, so finish out that table. Press pause, finish out the table real quick. All right, so check your table with my table. Make sure your numbers are the same. And then let's go and try to graph this. Now again, the biggest value I have is a 2. So I'm going to scale this. I'm going to kind of blow it up so we can see it a little bit better. So I'm going to scale. Usually the biggest, I just scale by a half. So that's now a half. This is now 1. That'd be 1.5, and this would be 2. So that's where our graph's going to go out to. So 0, 2, that's going to be my starting point. And then here's 30. So 31. So again, that's a half. That's 1. And then at 45, which is here, I should be at 0. So I went from here over to here. Okay? At 60, so here's 60, I'm at -1, so I should be going backwards. I should be going, this is 270, this is what, 240? I should be going towards 240. Okay, these angles are 180 from each other. So if that's 60, that's 240. So that's the direction I'm going. And I'm going 1. Remember, we're counting by halves. So that's -1. At 90, which is here, I'm going to go away from 90 to -2. So 1, 2, that's 1, 1.5, 2. Okay, so I'm going to kind of graph this as I go. So there's 90, -2. At 120, here's 120. If I add 180 to it, that's 300. So that's where I'm headed. I'm headed towards 300 right here. And then I'm back to 0. So, okay, so this is doing this. And then it goes back to 0. All right, this is looking unusual. 150, here's 150. I should be at 1. So a half 1. At 180, I should be at 2. So 1, 2, 3, 4. At 210, I'm back to 1. Here's 210. So I'm back to 1. And then I'm back to 0. Okay, so this graph goes up and around and then goes back. Okay. Where are we at? 225, 240. So here's 240, but we're going away from 240. So we're going towards 60. There's -1. At 270, I'm going away from 270. 1, 2, 3, 4. And then I'm at -1 again. You probably, once you start to kind of get a pattern going, you can kind of see where this is headed. It's going to head back to 0, so it's going to go up. Come back. And then again, we've got to finish this little branch right here. So it's going to be here and then back. And we get that. That's our shape. Now, if you look down at the bottom, this is called a rose. I know that doesn't actually look like a rose. Maybe a petunia? I don't know. So anyway, it's called a rose. It looks like a flower. Okay, so they call it a rose. These can get kind of unusual. I think there's one on your homework where it's like a 5-petaled rose. So do the best you can on that one. I give you some more points because you really kind of need to have some extra points to really get the shape of it. So when you see a big graph, just plug in the numbers I gave you, and see how it works out. Okay? So, but that's a rose. Last one. Okay, this is our equation. R squared equals 4 cosine 2 theta. Well, I don't want to know what R squared is. I want to know what R is. So for this one, R is going to be the square root of all of this, 4 cosine 2 theta. You could leave it like that. You could also pull the 4 out and write this as 2 and just the square root of cosine 2 theta. But that's what we're going to be doing. Okay, so in your calculator, so again, once we do the first one, if you've got a calculator that does this, so 2 square root of the cosine of 2 times, okay, that's what's going on, 2 times theta, so 2 times 0. I'm going to close those parentheses. I'm also going to close my original parentheses, and I get an answer of 2. Okay. And then I'm going to go in, I'm going to change that 0 to a 30. 1.4. I'm going to go in and get a 45. Okay, that's 0. No biggie. And then I'm going to go back and change that 45 to a 60. And I get a domain error. Alright, so what's happening? Remember, as we move around the circle, sometimes cosine values are negative. Well, because that angle's getting multiplied by a 2, it's going to happen pretty soon. When I take 2 times 60, I'm going to get 120. And when I take the cosine of 120, which 120 is technically in quadrant 2, that's a negative value. And I'm trying to take the square root, and that's not going to work. So I'm going to get an error message. Okay, so that point doesn't exist. That's okay. That point's not going to exist. So you're going to get another error message when you do that. That point doesn't exist. Okay, so you got to keep going. You're going to keep getting error messages. And then at 135, it works. You get 0. Now, it looks like we're going to have so what's happening here? We're going to have this big space in our graph. Well, technically we're not. Because where this graph ends, at the pole, this part of the graph picks back up. So you're not going to see a gap. So again, I'm going to scale by a half. So 0, 2, so 1, 2, 3, 4. I'm going to go out to here. At 30, that's 30, I should be at 1.4. So a half, 1, that's 1.5. So just inside 1.5. And then to 0. So it goes up, it comes back down. Kind of looks like the petal of that rose we just did. And then at 135, it's going to start up again. Okay. At 150, so what do we get when we type in 150? So let's go in, 150. Okay, we're back to 1.4, so there's our symmetry. And then it's going to go up to 2, I'll bet. Then let's go and put in 210. All right, 1.4. So we still got that symmetry going. There's 1.4, so I bet the next one's going to be 0. And then I got a feeling the next one, so let's see what happens when we put in 240. Yep, I get an error message. So that's an error message. 270 is an error message. 300 is an error message. Alright, now I'm back to 0, and then it's going to be 1.4, and then it's going to be 2. Alright, so let's see what happens here. So 135, I'm still at 0. At 150, so here's 150, I should be out at 1.4, so remember, half, 1, 1.5, so just inside. At 180, I should be at 2, that's right here. At 210, I should be back in at like 1.4. And then I go back to 0. So let's just go ahead and connect the dots. And then skip, skip, skip. Back to 0. So we're back at the pole. So there's no gap. We're just going to start right where we left off. And then at 330, so this is 300. This is 315. That's 330. I should be out at 1 point. There's 1, 1.4, and then back to 2. And I get that. Okay, that, again, that's a weird looking shape. Looks like a little bow tie or a airplane propeller or something. It's called a lemniscate. Again, I'm not sure. I don't remember if that's French. I'm not sure what it is, but it means ribbon. I do remember that. Okay, and so it's like this little ribbon that has been created. So again, not a big deal. Remember, if you see r squared, go ahead and solve it for r. That's going to create a square root, and then that's going to create some error messages. It's okay. Wherever you start getting those error messages, you're going to pick back up where you left off, so it's going to be fine. So take a look at your worksheet. Take a look at these. Plug in the values that you have. Graph them to the best of your ability, and then let me know if you have questions.